right? Because it was inclusive or it was not inclusive. So if we had something and we graphed an inequality and we got a dashed line, anything actually on that dashed line isn't an answer. Right? If it was a solid line, anything on the line was an answer. What did this shading mean?
Those are possible answers.
Those are also possible answers, right? So yesterday we were talking about graphing a line and the line gave us all the possible answers, right? And inequality said it could be the line if it was solid, but also anywhere that we shaded was an answer as well. Okay, so we said if we were solved for y, right, we had some shortcut rules. So these are just reminders from before, right? These work as long as they're solved for y. If it was greater than or equal to, we would shade above. Okay, if it was less than or equal to, we would shade below. Greater than or less than told us to use the dashed line. And greater than or equal to and less than or equal to told us to use the solid line. And hopefully at this point, we all say, yeah, I mean, I don't really need that again, Mrs. McKinney, because hopefully we understand why we're doing what we're doing. Okay? So if we understand the why we're doing what we're doing, it makes more sense of when we should use dashed or solid and so forth. Just like yesterday, there are three options when we graph lines. What are the three things that can happen when we graph two lines on the same plane?
Intersect.
They can intersect. William?
They can be parallel.
They can be parallel. Drew?
They could be the same line.
They could be the same line. Excellent. Unfortunately, today the options of answers then change because of the same catch we have had all trimester. As soon as we go from an equation to an inequality, our solution set becomes infinitely larger. Right? When we were solving equations, we went from one answer to an infinite number of answers. When we were graphing, we went from an infinite number of answers on a line to a line and then all of the shaded region around it. Okay, so that answer is going to look much different today because that solution set is growing. It's getting larger. Okay, so if when we graph we get intersecting lines, we're no longer talking about an intersecting point and one solution. We're going to be talking about an intersecting area, right? Because we have all the shading happening. So our answer is going to be the overlapping area. Which is an infinite number of solutions. When we graph and we get parallel lines, it's possible now that because we have this shaded areas happening, it's possible that we will still have an overlapping area. But it's also possible that there's no overlapping area and that we might get a no solution. Okay, so now when we get parallel lines, we have to choose between two choices. If they are the same line, it gets even more complicated because it's possible that we have an overlapping area. It is possible that we have a no solution, which seems really weird even though the lines overlap. But it's possible. We're going to talk about that. And it is possible that we get the same line. No, just a line. We don't need same. Okay, but the key here, I think, is not memorizing this table. The key here is understanding that this is going to function the exact same way as it did yesterday. We're going to do a solution set for one option, we're going to do a solution set for another option on top of it, and then we're going to look and see where they overlap. Today's problems are messy. There's a lot of graphing happening on one coordinate plane. So, if you would like to use multiple colors, it is a good idea, especially if you are a visual person. So if you have multiple colors, get out multiple colors. I put a box of colored pencils in the back of the room. There's also a box of colored pencils up here. So when we look at this, we're going to do the same idea we did yesterday. So we have two equations, two inequalities, two variables, and we're going to solve by graphing by putting them both on the same coordinate plane. So I'm going to look at this top one. Y is less than 4x plus 2. Is it solved for y?
Yes.
Yes. What does m equal?
4.
4. What does b equal?
2.
2. Is this going to tell us to use a solid or dashed line?
Dashed.
Above or below?
Below.
Now, plus I'm telling you, this information isn't going to be broke down for you on the test. I'm giving it to you because there's a lot of pieces to think about with all the shading and stuff to sort of help you break it down. Okay, but it's not like this is a requirement just to solve a system of inequalities. Okay, so to graph, we're going to start at 2. Then what?
Up 4.
Up 4 over 1. Right, I already see you guys all working ahead. So up 4 over 1. Okay, here it's not quite as important that we get a perfect line, but we do want a nice enough line that we could tell, because if the lines run close together, we need to see what's happening on each side. We said dashed, so I'm going to make a dashed line. Now, remember how picky I was about the shading when we just did inequalities? Right? We said not too much, not too little, not too dark, all the way across. So you're going to need to go all the way up to the line and all the way across the coordinate plane if you want to guarantee you're going to find the overlapping area.
Wait, isn't this supposed to be below?
Right. I'm just talking about how we graph. Okay, all the way up to the line, all the way across, right? So we don't want to do any of this. This is too dark, right? And we don't want to do any of this. Because then when we put other stuff on, we won't get a clear enough picture. Does that make sense? Remember how we were talking about that? Okay, so if we look at this specific one, which you all are already doing, right? In this specific case, we're going to shade below. So not too dark, not too light, not too much, not too light, right? Sort of that happy medium, all the way up to the line, all the way across the coordinate plane. Okay, if you don't get that whole area, then it's sort of hard to find what overlaps depending on what direction the line goes. Now we're going to go to our second equation. Y is less than or equal to 1/2 x. What does m equal?
1/2.
1/2. What does b equal?
0.
0.
Solid.
Is this one solid or dashed?
Solid.
Solid. Above or below?
Below.
Below. You all know how I love to have them shading below for some reason. So we're going to start at 0. Right, so here's where another color helps, because now you have to get these other points on top of the shading. Right, so up 1 over 2. Again, you don't necessarily need every point, but you want enough that you can get a straight enough line that you'll be able to see where they overlap, especially if they run close to each other. Okay, so we said we needed to shade below, so the next trick is making sure that you are shading below and not letting the green confuse you. So only look at the pink line. What's below is all of this. So all the way up to the line, all the way across the coordinate plane. All the way up to the line, all the way across. Have we noticed how messy we are yet? Because we're still not done. Okay, all we did right now was give ourselves enough information to decide what is the answer to this system. Okay, so when we graph these lines, did we get intersecting lines?
No.
Do those lines intersect?
Yes.
Yes. So we said we're looking for an overlapping area. So we're looking for where we see pink and green at the same time. Okay, do we agree that we only see green here?
Yes.
We see nothing here.
Yes.
We only see pink here. But over here in this section, we see pink and green. So we now need to represent that as our final answer. Which means either using a third color or graphing slightly darker, we need to show that from here to here is our final answer. Right, the colors are kind of helpful here. So graph a little bit darker, okay? Somehow make it clear that this area is your solution. And so I'm going to put some points on here that you do not need to put on your paper. I just want to make sure we're interpreting this correctly. So with all this jumbled mess, what does this mean? Okay, is point A solution for this system of inequalities?
No.
No, why not?
It's only in the green.
It's not in both, right? It's not in that final shaded area. Is B a solution for this?
Yes.
No. Wait, yes.
Yes. It's on a
'Cause it's
solid line.
Okay, so it's on a solid line, and is green also happening?
Yes.
Yes, so that's fair game. Tricky, right? But we have to think about it. Is C a solution?
No.
No, because it's on a
Dashed
line. Is D a solution?
Yes.
What do solutions mean? What makes it a solution?
If you plugged it back in, it would be a true statement.
Right? If we plugged it back into both of those functions, it would be a true statement. Does that make sense? Okay, flip your paper over. I'm gonna find the right one. Where did I put your stack? Oh, here it is. Okay, so when we're looking at number 2, what is one of the things we are gonna have to do on number 2 before we can do anything else?
Solve for y.
Solve for y. So right now I want you to get these solved for y, but don't start graphing. Just get them solved for y. You say we have answers? Bless you. Show of hands, who can tell me what sign I want to put in here for the second one when I solve for y? Show of hands. Feel confident about it? Abby, what do you say? Why? So our rule was when we are dealing with an inequality, if we multiply or divide by a negative, we have to flip the sign. Okay, so we need a y is greater than 3x minus 4. And our first one is y is less than or equal to 3x minus 4. So So what's our slope on the first one?
3,
3. What's our y-intercept?
-4,
Dashed or solid?
solid,
Above or below?
below.
Okay, let's all get this one graphed on our papers. These look good. Okay, what's our slope on the green one?
3,
3. What's our y-intercept?
-4,
Dashed or solid?
dashed,
Above or below?
above,
Okay, so let's get this one graphed on our paper.
How would we show that on ours?
Say it again, Mason.
Because, like, we're just putting dashes on the solid line. That
You might have to put your dash like right up against it.
Okay.
As long as you know it'll be okay when you do the answer either way. What's our answer going to be on this one?
No solution.
No solution. Do we all agree with that? We're all okay with no solution?
Yes, there's a solid line that we could win.
So there's a blue solid line. Why is the blue solid line not our answer?
Because the green's dashed.
Because the green's dashed, right? And they would both need to be on top of each other?
Yeah.
So is there any place that green and blue are both happening at the same time?
No.
I mean, it looks a lot like it's happening right here, right? But it's not because one of them is dashed. And so this is a no solution. Man, I hardly even tricked you guys. You have to write down no solution if it's a no solution. Now, what would be the change if all of a sudden this just became greater than or equal to?
That'd be the line.
Then it would be the line, right? So it's those really small details that are going to make a difference on those as to what the answer is. Are we okay there? So then the next one, I don't even know if I'm just going to kind of go through this. I just want to make sure for this one that we remember our rules of shading above and below. Okay, so x is less than 5 and x equals line looks like what?
Vertical.
A vertical line. So I'm going to positive 5 on my x-axis. All right, it's going to be dashed and below. So I think the big piece here is the discussion of not how we graph x equals, but what is below for a vertical line. Do we remember?
To the left.
To the left, right? Lower was left. To the left of 5 is smaller numbers. So we want this area. That's really the piece I just want to make sure we're sort of remembering and finding that right and left there. But we all seem to kind of be graphing. You're like, yeah, Mrs. McKinney, duh. Okay. Okay, so x equals 2 is what type of line?
Horizontal.
Horizontal line. So I'm going to go to 2. And I'm going to make a dashed line. And I'm going to shade above. So where's my answer on this one?
Top left.
Right, this space.